Welcome everybody to Tech with Newton, a podcast for technology news, insights, and trends that matter. A podcast where information, factual integrity, and entertainment intersect. I'm your host, Newton. Happy listening. In the previous episode, we defined information technology, dispelling all ambiguities surrounding the concept. Additionally, we journeyed down memory lane, tracing its origins all the way back to the Sumerians of Mesopotamia. We discovered IT was invented right there alongside beer. And coincidentally, the idea for the very first electronic digital computer was conceived after the inventor had a refreshing drink of bourbon. Makes you wonder, there is likely more to be discovered about the connection between alcohol and the invention of disruptive technologies. In this episode, we'll take a look at three more fundamental topics in the tech realm: ICT, computer science, and computer engineering. Far too often in my line of work, I come across the conflation of these terms, with information technology carelessly thrown into the mix every now and then. Albeit they all share certain similarities with multiple semantic overlaps, it is important to note that they are quite different from each other. They mean different things, the career paths for each are different, the education and training for each also different, and so are the job opportunities that will open up to you in the market if you choose to specialize in one or the other. By the end of this episode, the differences between these four pillars of the tech profession should become crystal clear. Information technology, as we have seen in the previous episode, is simply data technology. It is the usage of computerized systems to create, share, store, secure, and manipulate electronic data, with the purpose, of course, of fulfilling some form of human need. But what then is ICT? ICT stands for Information and Communications Technology. Although this phrase has been used by academic researchers since the 1980s, the initialism ICT only gained popularity after it was used in a certain report document which was submitted in 1997 to the UK government by British businessman Dennis Stevenson. That event, coupled with the inclusion of ICT in the revised national curriculum for England, Wales and Northern Ireland in the year 2000, introduced to the world for the very first time the term Information and Communications Technology. Not long after that, even the United Nations took a liking to the term, establishing a dedicated ICT task force charged with fixing the global digital divide at the time. Since then, the use of ICT has gradually morphed over the years into the conflation trap that it is today. Information technology is widely regarded as a subset of ICT, and sometimes they are used interchangeably, despite the significant differences between them. ICT emphasizes the use of technology for effective communication. It is a broader field than information technology, one which emphasizes the communication technologies used in the manipulation of data to produce information. ICT revolves around computer networks and telecommunication technologies, including mobile networks, telephone lines, wireless signaling frameworks, and enterprise communication software and hardware often used in the manipulation and transmission of data. You are likely to hear the initialism ICT used only in organizations, maybe educational institutions, or on many commercial IT platforms. The distinction between IT and ICT becomes apparent when you observe how and when each is used. For instance, when I was working at a telecom company a few years ago, I observed that ICT was used in speech only when there was a need to emphasize the communication side of IT. At such times, IT became ICT, and at every other time, it was just plain old IT. Keep in mind though, that whenever you hear ICT used in a commercial context, the speaker is likely referring to some form of telecommunication infrastructure or the communication software and services that run on those infrastructures, such as web or video conferencing, instant messaging, desktop sharing, SIM card management, and so on. Now, that is ICT. What about computer science? What does it really mean, and how does it differ from IT or ICT? Well, science itself is the study of the natural world through observation and experiment, while computers of today are electronic devices capable of manipulating data or information. Going by the definition of each word, it can be deduced that computer science is the study of computers, computing, and the technology they are built on. Once upon a time, there existed mechanical computers which did not use electronic parts but rather employed mechanical components like levers and gears. A notable example was the famous adding machine, specialized for bookkeeping calculations. Back then, these adding machines were ubiquitous in office buildings up until the 1970s when they were replaced by electronic calculators. Since then, mechanical computers have gradually phased out in favor of more efficient electronic computers, and people today tend to think digital whenever the word computer or computing is mentioned. The word computing here refers to work done by computers in manipulating data or information. Computer science is a broad field, a very, very broad field indeed. It can be studied in the university as a full 3 to 4 year course, and it encompasses subjects such as programming, artificial intelligence, bioinformatics, web development, computer networks, applied mathematics, cryptography, and much more. While computer science focuses on the actual development of functional software and some computer hardware systems, information technology, on the other hand, tends to focus more on the business or commercial usage of software and hardware systems to solve problems, as is done in many organizations today. So, while computer science is all about the development of computer systems, information technology is concerned with the application of computer technology to solve real-world problems. Computer science is predominantly focused on the software side of computers, with the hardware aspects touched upon sparingly, addressed only as and when necessary. The field of study that prioritizes hardware aspects of computers is computer engineering, as we will be discussing later. It is good to know that as a computer scientist, student, or maybe an employee, you will often find yourself immersed in issues related to software programming, artificial intelligence, machine learning, scripting, web and mobile development, etc. While as an information technologist, you will likely spend most of your time working in system administration, IT service management, enterprise technologies, IT network security, network administration, and so on. Computer scientists are likely to land roles such as software engineers, integration specialists, web developers, network engineers, and user experience or user interface designers. On the other hand, information technologists can get hired as IT managers, network administrators, system administrators, tech support engineers, IT analysts, and so on. This is not an exhaustive list of roles, but rather a small selection intended to steer your thinking in the right direction regarding the distinct fields of computer science and information technology. Also good to know is that in practice, there is no strict division between the job roles in IT and computer science. Hybrid roles and subjects that combine elements of both computer science and information technology are very common. Skills are transferable, and being a computer science graduate or professional will not hinder your ability to secure an IT job you qualify for. Same can be said for computer engineering, which is different from either computer science or information technology. Bringing in computer engineering into the mix. Computer engineering is a branch of engineering that combines computer science with electronic engineering to develop computer hardware and software. Computer engineers build and repair components of computers. They also engineer computer-based systems. These guys are primarily focused on optimizing computerized units by integrating them into larger systems where they can more effectively meet human needs. Robots, for example, are prime representations of computer engineering in effect. A typical humanoid robot, for example, is comprised of a variety of independent computerized systems and circuits, each one designed, built, and then systematically integrated by computer engineers to produce a fully functional robot. Computer engineering is believed to have first begun in 1939 when John Vincent Atanasov, an American physicist of mixed Bulgarian origin, assisted by Clifford Berry, an electrical engineering graduate from Iowa State College, started developing the world's first electronic digital computer together. They are believed to have applied their accumulated years of experience and knowledge in physics, mathematics, and electrical engineering to create the world's first electronic digital computer called the ABC, which stands for Atanasov Berry Computer, their last names. This device weighed a whopping 700 pounds, it contained approximately 1 mile of wire, and was the size of an average office desk. Modern personal computers did not emerge until later in the 1970s, after several breakthroughs were made in semiconductor technology. Most entry-level computer engineering jobs require at a minimum a bachelor's degree in computer engineering or computer science. A sound knowledge of electrical engineering is also required. In addition, a working knowledge of mathematics, particularly in subjects like calculus, algebra, and trigonometry, will certainly come in handy on this career path. And depending on the job requirements, you may need to familiarize yourself with common programming languages, as computer engineers are also known to write and debug software code on a regular basis. Unlike computer scientists, computer engineers are expected to have a deeper understanding of the hardware components they work on, in order to build or repair them whenever necessary. Also, you just can't go wrong pursuing a career in computer engineering today, especially as knowledge of computer engineering is increasingly sought after, more so now in an IoT-driven world than in the last decade. And there you have it, a breakdown of all four fields: IT, ICT, computer science, and computer engineering. Hopefully their nuances and career paths are much clearer now and will remain so for a long time. And on that note, I bring this episode to a close. Thank you for tuning in, and be sure to like, rate, and subscribe to the podcast on its social channels. Oh yeah, and do send in your feedback as well. Until the next episode, cheers!